This is Mathematics Chapter 2, Complex Numbers. So our first question is a passage question which says we have three sets A, B and C. Set A has Z colon imaginary part of Z is greater than 1. B is mod of Z minus 2 plus I equals to 3. Then C is Z, real part of 1 minus I in whole into Z equals root 2. Right. Now the first question of this passage question is how many elements are there in A intersection B intersection C. Okay, we have four options 0, 1, 2 till infinity, right? Then we have second question which says that let Z be any point on this set, right? So they're saying Z plus 1 minus I commod square plus Z minus 5 minus I commod square lies between which of these? Then the third part says let W satisfy mod of W minus 2 minus I mod is less than 3. Then mod Z minus mod W plus 3 lies between which of these? Okay, so let's go start the first question. Now let Z be x plus iy, right? So that means A is the set A means is basically denoted by the points above y equal 1, right? If this is the Argand plane and this line is y equal 1, so all these points is A. B is a circle of x minus 2 whole square plus y minus 1 whole square equals 3 squares. Basically a circle with center at 2, 1 and the radius as 3, right? And C means after solving a bit real part of this complex number, we get x plus y equals root 2. So this line, all the points on this line signify C, right? Now we are told that we have to find the number of elements in this set A intersection B intersection C, right? So now there are 2 points. Okay, there's only one point which satisfies all three in A, on B and C, right? This is point P here. So that means there's only one point in this intersection, right? So 1 is our answer here. Now let's go. Okay, so we know that in second question it says let Z be any point on this, but there's only one point on the intersection, right? So that means Z can be represented by P there, right? So we know that. Now taking this equation, okay, this plus this square, okay, that basically means that there's a point A, there's a point B on this circle, right? And the square of this distance and the square of this distance is basically our thing here, right? So now you can see that this is a semicircle. Okay, this is a triangle in the semicircle with this as the diameter, right? So that means AP square plus PB square equals AB square, right? And AB square is obviously 6 square because 3, radius is 3, right? So 36. Therefore it lies between 35 and 39. So this is our answer here. And now the last question. Now W minus of 2 plus I is less than 3. That means W lies inside the circle, right? Now since it lies inside the circle, if you subtract Z, which is on the circle, which is here, minus any point, Z is here, minus any point W inside the circle, it will always be less than 6, right? So the most will be here, right? This will be 6. Sorry, here, this, here, right? So Z minus W there will be 6. Not equal to 6, but almost 6. So we know this. Now we know that mod Z minus mod W is always less than mod of Z minus W, and this is a property, and we know that this is less than 6, so that means this is less than 6. Now we take out the mod and we get this minus 6 is less than mod Z minus mod W is less than 6, right? And now here we just add the 3 to get our to get this expression, right? So therefore we add 3 and we get this. So this expression lies between minus 3 and 9, right? So since it lies between minus 3 and 9, our answer will be this, right? Okay. Now that's the first passage question. Now let's move on to the second question. Right. Okay. So the second question says, okay, alpha and 1 by alpha conjugate lie on this circle C1 and 1 by alpha conjugate lies on this circle C2, right? Let Z naught be x plus y, I naught y naught, I y naught, and 2 into Z naught mod square equals R square plus 2. What is alpha mod? Okay, now we've been given all these. Okay, to solve this, what we first do is, we know that alpha lies on this circle C1, right? So therefore, the distance between alpha and the center, which is x naught, which is Z naught, right, will be R square, right? So we do that, and we know that this property, that if there is a Z square, right, this is Z into Z conjugate, right? This is a very important property. So we use that here and we get this as R square, and we open the brackets and we get this equation, right? This is the first equation. Now we know that 1 by alpha, a conjugate, lies on the second circle C2, right? So therefore we get this expression, right? We again open the brackets and we get this 2. We get this equation, right? Now we subtract the second equation with the first one and we get this, right? We can take alpha square minus 1 as common here and we get this. Okay, now we know that it is given that 2 into Z naught square equals R square by 2, which can be put in this form, and we put this here. Okay, we get R square by 2. R square you can cancel easily, right? And you solve this and you get alpha square as 1 by 7, which means alpha equals plus minus 1 by root 7. But the modulus cannot never be negative, so this minus sign goes away and it's only 1 by root 7. So this is the answer. Okay, that's our second question. Now we'll go on to the third question. Okay, so in the third question, it is given that there's a number Z, a complex number Z, whose imaginary part is not equal to 0, is non-zero, so it's basically always imaginary, right? Then we're given that a equals z square plus z plus 1 when a is real, right? So we have to tell which value of these a cannot take, right? So there are two methods. This is the method I did, but this is the alternate method, which is actually very easy and it's a one-liner. So in this one, what I did was we take z as x plus iy, okay, the usual stuff, and we simplify a in terms of x and y, right? Now it comes as this, and now we know that um, this imaginary part of it is 0, right? Now we get this. Now we know that y cannot be 0 because imaginary part of z is not equal to 0. So that means 2x plus 1 has to be 0. So x is equal to minus half, right? So from here, from this expression, a becomes um, from the since it's real, so a equals x square minus y square plus x plus y. So a becomes 3 by 4 minus y square when you put x equals minus half, right? Now we know that y equals y does not equal to 0, so minus y square is also not equal to 0. Now you add 3 by 4, that means 3 by 4 by minus y square is not equal to 3 by 4, which is basically a. So a is not equal to 3 by 4. Now the alternate is basically you say that z is imaginary, right? So this quadratic z square plus z plus I 1 minus a equals 0. Now we know that z is imaginary, so the discriminant of this is less than 0. That means the roots are imaginary, right? So if discriminant is less than 0, then you get this expression, and a is less than 3 by 4. And out of all these, only this does not satisfy a here. So answer is this. Now the third one is done. Now let's go on to the fourth question. Okay, in this they say a, b and c are not all simultaneously equal integers. Minimum of mod a plus b omega plus c omega square is what? Right. So in this question, this a, b and c are not simultaneously equal is very important. This basically means that two of them can be equal, but the third one has to be unequal to the first two, right? So, okay, in this question, we basically, okay, omega is basically cube root of unity here. So omega is minus 1 plus root 3i by 2, and omega square is minus 1 minus root 3i by 2. Okay, so we make this into one single complex number, right, as this. Okay, now once we get this, we can solve it. Okay, now since we get a what do you call a complex number, we can solve the modulus and get this. Okay, we expand this to get this, and this can be simplified to this form. Okay, now this form is very important, and it's an easy simplification. 4a square, you take 2a square, 2a square, 1 2a square goes with 1 2b square, 1 2a square goes with another 2c square, so 2a square plus 2b square, and there are there are 4 BCs, right? So you take one of the 2 BCs, and so basically you get this in, right? So that's why there's a 1 by 2. So you take the 2 out of a square, b square, and 4 minus 4 is ac, right? So you get a square plus b square minus a square plus b square minus 2ab, right? By 2. Okay, so like this you can get this expression. So now this is the expression get for this, right? Now the minimum value of this is obviously 0 when a equals b equals c, but this is not possible because they're simultaneously not equal. So the minimum value will be when either two of them is 1 and the other one is 0, or two of them are 0 and one of them is 1, right? Then the answer minimum value will be, for both of them the minimum value will be 1. Okay, so now the fourth question is also done, and let's go on to the last question. Okay, now in the last question it is given that omega is v is e to the power 1 I pi by 3. Okay, now this is the question, and I pi by 3 basically converts to this 1 plus I root 3 by 2. It is given that there are 6 of these symbols a, b, c, x, y, z. So we know that the relation is a plus b plus c is x, a plus b omega plus a plus bv plus cv square equals y, and a plus bv square plus w equals z. Right, and this is an integer type question. You have to remember that. So now we have to find the integer value of this. Not integer, as in this is an integer type question, but the answer can be in decimal, which you have to round it off to the nearest integer. Okay. So now in this question, this is actually a bit manipulative. So you just put a equals b equals c. Okay, you say that, and then you get the value of x equals 3a and y equals a into 1 plus root 3, because omega square is minus 1 plus I root 3 by 2. Right, from here we can find out this. So y equals z. Right, and it is this. Now mod of x square will be 9 of mod of a square, right? First you mod it and then you square it. Now first you mod this and then you square it. You get this as the mod of this will be 2 and the square of it will be 4. So 4 mod a square. So it'll basically be x square, which is 9a square. Y square and z square are the same, so 2 into y square. 2 into y square matlab 2 into 4 into mod a square, and these three are equal, so 3a square. Now you get this as 17 by 3, which can be rounded off to 6. Now an alternate question will be when when w is actually omega, which is basically cube root of unity, right? So e to the power of I 2 pi by 3. Now for that you need to take a different approach. You can simplify this into this, right? We discussed it in the previous question, z and z conjugate. Now this can be split into this, a plus b plus c whole into a conjugate plus b conjugate plus c conjugate, and the next term will be a plus b omega plus c omega square into a conjugate plus b conjugate into omega square, which is basically omega conjugate, plus c conjugate into omega, which is basically omega square conjugate, plus z conjugate. Okay, I've not written that, but you know what it will be, and denominator will be same. Okay, now once you open up the brackets here, you get 3 into mod a square plus 3 into mod b square plus 3 into mod c square, plus there's this pattern of a conjugate b plus ab conjugate plus a conjugate plus blah blah blah, and you take this common and you get 1 plus omega square, right? And we know that 1 plus omega square cube roots of unity is basically 0. So that means that only this term is left and the denominator is this. So those two get cancelled and you get answer as 3. Yeah, thank you.